Begin. All right, so I would like to welcome you all, those who have already joined us, presenters, and also thank you to Natalie for your efforts putting this together. It's always not so easy, and you're always there ready to support and provide this platform for us when we need it. Okay, so today we are having a webinar, and it's more like a report on the recent training that took place in China, Xindao. And ECOP Africa was presented by a few young people, Samuel and Abiwe, but also a lot of other ECOPs from around the world at this training on mooring design, deployment, and retrieval. And this training was sponsored by Pogo. And as we all know, with such trainings, we can only admit very few, limited number of people. And for the hundreds others who couldn't attend, Samuel brought up the great idea to organize this webinar and at least give a general overview of what happened at the training, and also to kind of introduce a topic to those of us who do not really know much about the design and deployment of marine oceanographic instruments. So for that, I would like to thank you, Samuel and Abiwe, for this. And also thank you, Tegu, and for joining in and to support, take questions and related to the training. Okay, so without further ado, we have 14 participants presently. So I would go directly to introducing Samuel. All right, so Samuel is one of the very first ECOP Africa members I got to know when I started as the coordinator of ECOP Africa. And for those of you who do not know me, I am the current coordinator of Education Professionals Africa. And I'm also an ecosystem scientist at Plymouth Marine Lab in the UK. And I started as a coordinator in October last year. And so still to be 1 year into the job. And it's been a very interesting ride. Met some amazing young people throughout this journey, people like Samuel, who have been so inspiring to me. And ECOP, just to say a few words about ECOP. ECOP is a UNDP endorsed program, which is currently under UNESCO IOC, and it aims to give a voice to young people and empower young people in the marine space to become more proactive and to have a voice in not only identifying and dealing with oceanographic and ocean-related issues in their countries and in the world, but also to be able to participate at the global stage and boost their abilities through capacity development and a lot of opportunities of building networking with other ECOPs around the world. So ECOP is actually moving in the direction of becoming a network of networks, which is inclusive of all early career professionals who identify as being early in their career and working within the marine space. And so for that reason, ECOP is actually quite unique. And ECOP Africa, being one of the regional nodes of the global ECOP program, and it's also coming up strong with a diversity of young minds and who are very dedicated to bring about meaningful change in Africa and to help the continent move in the direction of sustainability and sustainable blue economy. And so with that brief introduction, I would introduce our speaker, normally we're supposed to have two speakers today. Unfortunately, the second speaker is out field work. So Samuel Obeng is a marine scientist who had his bachelor's in marine science from the University of Ghana and currently a final year graduate student at Ohio University in China. So he specializes in harbor, coastal, and offshore engineering, and his research interests include marine observations, coastal hydrodynamic modeling, offshore fluid structure interactions, mooring analysis, and offshore structures. So the second speaker who was supposed to be here today and who's not here, but I would have to introduce him, is Viwe. He's from South Africa, and he's also a marine aquaculture and marine aquaculturalist and oceanographer, and he's a junior oceanographic engineer in South Africa. So he has experience in species identification for Patagonian toothfish, tuna and tuna-like species, pectoral and bycatch species. Abiwe has been involved in fisheries independent monitoring surveys as a marine research assistant. So both young people have very rich resume, and as we move towards increasing our visibility in the marine space regards to research and also the development of projects in Africa, engineering is one of those areas where we are really lacking, especially marine engineering. And so people like Samuel and Abiwe stand out and will be the future of marine engineering in Africa in the coming years. And so I'd just like to welcome Samuel to take the floor and give us a presentation, and which will be followed by questions and answers. And there are also some of the participants in the house from Indonesia who were part of the training as well, and who will also be ready to take questions at the end of the session. So if you have any questions, please kindly use the chat or the question and answer area. And if you have any other suggestions or anything you want to mention, please use the chat. And the meeting, this webinar will last for roughly an hour. And so it will be interactive towards the end. So you'll be ready to ask your questions and interact with the speakers. All right, so in order not to take much time, I would like to welcome Samuel to take the floor and start his presentation. The floor is yours, Samuel.
Thank you so much, Dr. Anthony, for the great introduction. As already said, my name is Samuel Obeng Buama. Please, can you hear me? And I hope everything is okay. Yes, right. So my name is Samuel Obeng Buama. I'm a graduate student of Ohio University. I've been introduced already, so I would head directly to why we are here. Today, it's going to be knowledge sharing. This is a report on mooring design, deployment, retrieval. And this program was held in Qingdao, China, and it was sponsored by Pogo. So today, we are going to be talking about a little bit of introduction into observational oceanography. We will talk about subsurface mooring design, what it is. We'll talk about mooring deployment. We'll talk about mooring recovery. We are also going to talk about the role of in-situ observation. And then we'll delve into mooring data processing and analysis. So ocean observations are the basis for major breakthroughs in oceanography. And there are various forms of ocean observation. It is obvious that it is very important that we observe our oceans. There are various forms of ocean observation, and we have the remote sensing, satellite remote sensing, satellite altimeter, and area remote sensing. We also have the in-situ. Actually, as we know, there is no observation method that is superior to the other, but these two observation methods complement each other. and it gives us a comprehensive observation of the ocean. So we also have the in situ, we have the research ships, that is a observation that is done on vessels, that's merchant ships. And we also have the autonomous research observation, the drifting, we have the Argo floats and the gliders. And then we have fixed observations. We have the ocean buoys and the subsurface moorings, which are fixed at a fixed point, unlike the autonomous where Argo floats have been drifted, unlike remote sensing where we observe the ocean from satellite altimeter. So on my right, as we can see, we have the buoy, we have the satellite altimeter, and we have the Argos. Now, when we talk about in situ sampling, there are various sensors that are carried on various platforms, and these are some of the parameters that are very, very important to measure in the ocean. Ocean temperature is very important. We also talk about salinity. We have instruments that measure the salinity of the ocean. We also measure ocean pressure, ocean depth, velocity, and we have current meters to measure ocean currents. And then we have the ADCP. We have the acoustic Doppler current profile also for currents. We have the floats. We have a parameter for oxygen where we measure ocean oxygen, also for conductivity as well. And on the right, we have the carousel water sampler. So these are some of the parameters of the ocean, both biological and physical, that are very important for us to measure. So let's talk a little bit about remote sensing. Satellite observation, we are able to measure global sea surface heat, temperature, trajectory of ocean eddies from spaceborne platforms. Remote sensing has largest horizontal scale, but not vertical. This is very important for us to note that with satellite observation has the largest horizontal scale. So we are able to measure the horizontal scale of the ocean, but does not have the vertical potence, unlike the moorings as well. So it is important that we measure ocean surfaces. It is also very crucial that we know what is subsurface of the ocean. So these are these Argos. Argos are moving observation and autonomous ocean profiling device, which is equipped with sensors for collecting data. For collecting vital ocean data such as temperature, salinity, ocean current. Also, data collected by Argo can be used to validate and calibrate ocean surface measurements such as sea surface height and temperature. So this picture here is as at 12 July 2023, Goose Argo network. This is the in-situ Argo networks that we have, and these are autonomous ocean profile devices. They are very, very crucial. They help in measuring ocean temperature, ocean salinity, and ocean currents. So I'm going to be taking it one after the other. So this is the status of in-situ observing systems. So I want to talk a little bit more about the in-situ observing systems before we go into the mooring. So this is the status of in-situ observing systems in 2022 by Goose. So the various parameters we see at what we have the ship-based meteorological, we have the sea level gauges, we have the time series sites, we have the moor buoys, we have the tsunami buoys, and this is spread across oceans, which is very important for us. Now, mooring observation. This is a type of in-situ observation. It's a fixed point observation. So it's an effective way, or it's an effective fixed point platform for long-term series observation of the ocean full depth. It is very important that we measure our subsurface ocean or our deep oceans to know what goes on right there, as well as the surface of the ocean as well. So this is what a typical mooring buoy looks like. On the right, we see a long line. That is a long line with various ocean observing instruments that is anchored at seabed. So on the left, we see a picture from Hural 2019, observation 09, that is giving us a stratified pattern of the ocean from ocean surface to 2,500 meters below sea surface. So mooring observations helps us. They are fixed points. They give us time series observation of the ocean from surface to deep oceans. To obtain real-time, this is a short evolution of ocean observation. To obtain real-time data in 1990, satellite realized real-time surface information. In 1994, the Triton buoy network in the US and Japan by Jamstec also realized real-time data. Now, in 2016 to 2018, IOCAS, that's Institute of Oceanology, Chinese Academy of Sciences, realized real-time and long-term transmission of temperature and salinity and currents from the surface to 6,000 meters below the sea surface. However, there were issues with battery and technology. In 2017, they improved and got a better result. So from down there, we could see arrays of buoys for observation. And then this is how ocean observation has evolutionized from satellite observation into mooring observation to time series, long-term time series observations, what is very important for researchers and for us scientists to understand our oceans and how it affects weather patterns and how it affects humans on Earth. So the design of a mooring buoy. Moorings give very important time series information. They give depth balance. They help to observe the vertical stratification of the ocean to give better understanding the dynamics of subsurface ocean. So on our right, we can see that this is a very simple subsurface mooring. It consists of a main float that floats at the surface of the ocean. It also has floats in between for buoyancy. In between there, we can also see the current meter. It also has the acoustic releases and the anchors. Moving forward, we are going to take some of these instruments one after the other, and then we'll delve more into it. And also to understand, moorings help to understand deep ocean circulation, the impact of long-term global climate interaction with upper ocean, sparse observation, and deep ocean observation. So moorings help us, as I mentioned earlier, get a vertical stratification of ocean to better understand the dynamics of subsurface oceans. So it has the main float, it has the float, it has current meters. So this is a very simple mooring design. And actually, subsurface mooring can be engineered, can be altered in your own way to fit your description. If you are a biogeochemical or you're an ocean biogeochemist, you can add instruments that will help you in your chemical observation. If you're a physical oceanographer, you want to investigate currents and physical parameters, you tailor your observation instruments according to your research. So a typical subsurface mooring design, an oceanographic mooring consists of a long line, a cable anchored at seabed, a float at the other end, and oceanographic observation instruments attached to the line in between or to the float at the surface. These moorings systems allow researchers to measure properties such as water temperature, salinity, velocity at different depths over the water column for a very long period. They also allow scientists to explore the complex interaction between ocean and atmosphere that are difficult to monitor from satellites. So basically the mooring structure helps us to monitor deep sea parameters or deep sea variabilities that are very difficult to measure from satellite observation. So this is a little bit complex. This is a little complex mooring structure. This particular mooring design has a main float. It is equipped with 75 kilohertz of ADCP upward and downward, which are used to obtain high spatial and temporal resolution velocity of surface to about 1,000 meters. So this, and then it also has several single point current meters. Single point current meters are placed from 1,000 meters to the bottom to obtain the time series of deep ocean velocity. This also has several CTD, TD, and T for temperature. They are placed from 400 meters to the bottom to obtain time series of temperature and salinity. This is also equipped with 2 acoustic releases and equipment equipped at the bottom to ranging position and recovery. Don't worry, we'll delve more into it. If you're not familiar with some of these instruments, we'll take them one after the other. So it is very important that we calculate the net buoyancy of our mooring designs, because you want a mooring design that is stable. You want a mooring design that has structural integrity. So the net buoyancy of mooring designs, most times, for an efficient observation, it has to be positive, above 300. Okay, the next buoyancy has to be above 300. So this is previously I showed you this, and this is the net buoyancy calculated for the mooring design. So yes, this is a typical what at Qingdao we were able to put together this mooring design. So I wanted to show it to you for you to have a look at it. You can see we have floats at the top right here, and we have another float here. We have the acoustic Doppler current profiler here. We have the transponder here. So yes, we are going to delve more into it. We will take the instruments one after the other. So what are some of the instruments that are attached to the mooring line? To be able to have a robust mooring line, we need mooring floats. So right in Qingdao, this is the exact float we used. You need a mooring float that would help keep your mooring subsurface mooring buoyant and afloat. All right, whilst it is anchored at seabed. So you can have certain buoys like this. The size of the buoy, the buoyancy of the buoy should all depend on the instruments you are putting together, so that you would be sure, because in offshore environments there is high waves and currents are unpredictable. So you want a mooring design that is very robust and that is very, very, very safe. Okay, so we also have the several single point current meters, the aqueduct single point current meters. They are placed at several distances to the bottom to obtain the time series of data ocean velocity. So it's very important. These current meters measure ocean current velocity. So as you have arranged your mooring design, you can place these current meters at the distances that you wish to measure current, or the velocity, ocean velocity, deep ocean velocity, I mean. It is also, ocean buoys can be used to measure surface velocities, but when you want to measure deep velocity, say 50 meters below the sea surface, say 100 meters, 1,000 meters, 5,000 meters, you attach this aqueduct single current point meter to your mooring device for you to be able to measure deep ocean velocity. This is a CTD, several meters to the bottom, to obtain time series of temperature, conductivity, and depth. So this is a typical example of what we used, and this will help give you a time series observation of subsurface or underwater. Okay, several meters deep ocean. This will help give you the data for temperature, for you to be able to monitor temperature, conductivity, and depth. And subsurface moorings are very important because they are fixed. You are able to obtain a long time series, say for a year. When you fix your subsurface mooring, you are able to measure continuously, maybe the conductivity or the temperature stratified at the vertical stratified area of the ocean for a very long time. And then processing this data, you are able to have better understanding into new phenomena of deep ocean. So this is me right here standing by the carousel water sampler. This SB32 carousel water sampler collects water samples at different depths to analyze the distribution of chemical elements, nutrients, dissolved gases, and pollutants. Water samples provide data on temperature, salinity, and other physical properties of the ocean at different depths. So this water sampler helps sample water at different depths, and it helps us to be able to make chemical analysis, check the concentration of nutrients. And it is very important for us to note that for you to be able to assess eutrophication in any deep water or any part of the ocean, you need to be able to check the temperature nutrient concentrations, because this process can lead to harmful algae blooms. So this carousel water sampler helps us biogeochemists and biological oceanographers to be able to sample water at different depths, to be able to perform experiments at different depths and check the data for what's happening in our deep oceans based on temperature, salinity, chemical, nutrient, dissolved oxygen, and CO2 as well. So yes, this is also a very important instrument that can be attached to your mooring line. We also have we use the SBE56T. This is a data logger for temperature. This is used to measure temperature. So this can be attached to your mooring at depths that you want to investigate the temperature. This helps because when you are trying to investigate subsurface marine heat transport, it's very important to have instruments attached to your mooring line at different depths to check the temperature data. This is one very, very, very important equipment. This is an acoustic release transponder, okay? This is equipped at the bottom to range in, position, and recover to the anchor. This is very important. As we can see in the picture, the yellow gadget is called the acoustic release transponder, and we could see that it has been attached to the anchor. It is very important because after you have deployed your mooring, and let's say you want to recover your mooring, you have to be able, we have to be able to make sure that our instruments are afloat, or they've floated to the surface of the ocean so that we can have it. So this acoustic transponder, moving forward, we are going to learn about how it works. It can automatically dismantle itself and allow the ocean observing instruments to come afloat. So it is a very important instrument. It also helps us to be able to locate where we have deployed our subsurface mooring. And with the subsurface mooring, we use what we call the Kevlar cable. This is a fiber optic cable. It is a very reliable cable because when you are deploying a subsurface mooring, or a mooring in any case, let's say ship mooring or ocean buoy mooring or whatever it is, you need a cable that that can be reliable. You need a cable that is durable. And we also have to understand that the ocean environment is a bit rough, and previously nylon and some cables can absorb water, and you have to know that the salinity in the ocean is also very high. So you need a cable that can withstand prolonged time series of observation. And even with this Kevlar cable, it is very important that after a year of every deployment, we learned that it is either retrieved. Some could be reused if they are in good conditions, but if they are not in good conditions, then they have to be replaced so that you don't cause financial loss whilst you are doing research. You have to make sure that you don't end up in a situation where you've deployed a buoy and then your cable failed. So we use the Kevlar cables. This is manufactured in China. We had the opportunity to visit the company that makes these cables, and that is quite interesting. It's a brilliant technology right there. So this is a general view of what a subsurface mooring looks like. So I decided to put together this video. So if you would like to watch again, we have the anchor, the transponder, we have the float, we have the current profilers on the mooring line. So yes. Now, this is also very important. As an oceanographic engineer, as I mentioned earlier, offshore environments are unstable and unpredictable. So it is very important that you perform numerical analysis. It is very important that you perform numerical analysis for your subsurface mooring. So perform numerical analysis or mooring analysis of mooring to check the attitude of the cable and its tension to ensure stability. So this is more like a numerical analysis. We are predicting the nature of the mooring line, and when subjected to environmental loadings like waves and currents and winds, you want to make sure you perform numerical analysis to examine how your mooring is going to behave. You want to make sure that the tensions in the mooring lines at anchors and at fair lead do not exceed their tension limits or their breaking points. Because if you have a cable or a mooring system that is not buoyant enough, that is not anchored well enough, and when subjected to, you are deploying a buoy in a subsurface mooring in the oceans, maybe 1,000 meter depths where environmental conditions are high, maybe high winds, high currents, high waves. So you have to, what we do is that we model our subsurface mooring, check the tensions, make sure that the tensions over a period of time does not exceed and actually you subject this to extreme environmental conditions so that you are sure that your mooring is very reliable. So this is an open source software on MATLAB. You can find it. I have the link right there for mooring design, which was designed. It was designed as an open source software. You can use it to model your subsurface mooring to be sure to ensure that the tensions are quite low and they are reliable. Now, this is also very important. There are 3 stages of deploying a subsurface mooring. We have the preparation, the deployment, and the after deployment. So the vessel you see there was the vessel that we deployed our buoys on in China as we went for the training, and you can see our equipments right there on your screens. So what we do at the preparation stage, we set up the well-maintained instruments, renew batteries, and empty the memory card. So it is very important that before you attach your instruments to your mooring line or to your subsurface mooring, you have to make sure that you have renewed your batteries. You have to make sure that you have emptied your memory card. You have to well maintain the instruments. You have to check all the checklists, make sure that you are putting in a memory card or memory slot that is well empty and can receive new data. Your batteries are renewed and they are new so that it can survive long-term operations in offshore environments. Okay, so preparation. We also prepare the cables and float balls on the deck. So before you deploy, as you can see right there, you need your cables well arranged. You need the moorings. You need your buoys and your transponders. Everything set right on your vessel as you sail to go and deploy this. Now, preparation. We also assemble the mooring chains. So we have to make sure that it is very important. Offshore conditions are very, very, very extreme. They can be very extreme. So you have to make sure that you have assembled your mooring chains and your mooring lines very well so that you don't have any accidents or you don't have your subsurface mooring destroyed. Now, we test the acoustic releaser. This is acoustic releaser. And on the right, you can see that it is linked directly to the anchor. So right here, you have to test it. You have to make sure that it is working very well. And once the acoustic releaser is released, it allows your float to bring up all your measuring instruments. So I put together a short video of how the acoustic releaser works. This is how it works. You can have a look again. It is controlled by an instrument, external instrument. And then once it is done, it releases itself. It helps to detach the observation instrument from the anchor so that your instrument can come up once you want to retrieve. Now, before you deploy, it is very important for us to do a preparation because we have to check the terrain. So we choose a target location. So for instance, you're trying to check the vertical stratification of the ocean. You're trying to do analysis. Let's say you want to do temperature with salinity or currents at maybe a depth of 50 meters, and your mooring line is maybe 50 meters for 50 meter depth of ocean. You do not sail into waters that are deeper than what you want to do. So you can't sail into like 100 meters where you can't drop your anchor. So you use your multi-beams, you scan the area, you scan the area to check the right place, the right target location that you want to deploy your buoy. Now, during the deployment, you choose the target location and then you make sure that you get where you want to deploy the buoy. Now, deploying the mooring chain from the top, keep speed not as 1 to 2 knot relative to seawater. So it is very important that the mooring lines are arranged, okay, from the buoy to the anchor. But so what we do is that the first thing to go inside is your first buoy, that's your top buoy, and then the last instrument to go is your anchor. So it is deployed from the top to the bottom, and then you keep your speed between 1 to 2 knots relative to seawater so that you can move slowly and you have a safe deployment. So I put together this short video for you to see how it is deployed. So this is the anchor going in this time, placing the anchors, and then you would realize that once the anchors touch the seabed, all the mooring buoys are gonna they are going to be submerged and then be in a vertical straight form right there. So that's what is happening right here. So you can see once the anchor touches floor or start to go deep, the buoys begin to submerge. That is what we are seeing there. Yes, right there, if you can see it. Right there, if you can see it. Okay. Seconds to go. Okay, great. So now, after you had deployed, so that was a short video of how it was deployed. So now, after you have deployed the subsurface mooring, it is also very, very, very important to know the position of your deployed, buoy. Okay. So what we do is that the ship is going to take 1-point location. So we do a 3-point positioning. All right. The ship is going to take 1-point location. We check the location using the transponder. We are able to check the distance from the ship to the point of deployment. And then the ship takes another location, checks the location from where we are, and then takes the third location, checks the distance from where we are. And then we kind of have like a triangle, and then we are able to intersect at the point where we know that this is where our buoy was deployed. After which, we disable the acoustic releaser, and then we know that we are done with the deployment. So basically, preparation of deployment takes about 7 hours per experience, as was shared with us. Deployment takes about 2 hours, and then after deployment takes about an hour. Now, recovery. It is very important that after you have done your observation, deployed your instruments. After about a year, it has to be brought out, or it has to be taken out of the recovered, and then we check on the data and see what we have. So before you go, you have to locate the accurate position, the acoustic transponder release. So it is very important. Once you see the location where you deployed your buoy, then you use the transponder for the acoustic releaser. Once you release the acoustic releaser, as we saw in the previous video, it is automatic. Once it is released, the buoy lifts up all your instruments. Then you're going to use your recovery hook to hook up your mooring lines and make the recovery very, very, very easy. But it sounds easy, but when you are in an offshore environment, when you're in an offshore environment when it is not stable, it is very, very easy to do. I remember when we were doing this, we took about 3-4 hours just trying to hook this up with the mooring buoy. So it is easier said than it is done. But basically, this is the methods and the procedure to do so. So that's me right there. So you could see I was holding there. I was just trying to check the position of where we deployed the buoy. So you need to find it first, find out the floating ball after you have released them with the transponder, and then use your hook to recover it. Now, when recovering, so this is when we were about to recover. You can see down there in the picture, this is when we're about to recover. You have to keep the ship speed between 1 to 2 knots relative to the seawater. Then you disassemble the instrument from the top to bottom, which is very important. Now, after recovery, it is very important. Now you have acquired the data you want. This has given you a longer time series data for about a year. You've been able to measure ocean temperature, salinity, whatsoever. What are you supposed to do? We have to load the data and maintain the equipment. So after a year, we recover, we load the data onto our computers, and then we maintain the equipment. So recovery also takes about 3 hours, 2 hours preparation, 2 hours recovery, 3 hours after recovery. So this is what I just described previously in the previous slide. Now, let's talk about the role of in-situ observation. Why do we need to be able to deploy subsurface moorings? Robert H. Stewart once said, the lack of sufficient samples is the largest source of error in our understanding of the ocean. So if you lack samples, it's going to be a hindrance to understanding of the ocean. And then Carl Wunsch also said that the absence of evidence was taken as evidence of absence. The great difficulty of observing the ocean meant that when a phenomenon was not observed, it was assumed it was not present. The more one is able to observe the ocean, the more the complexity and subtlety that it appears, right? So what he's trying to say is that when you lack evidence, okay, the absence of evidence is taken as evidence of absence. So once you have not found out a phenomenon, you think the phenomenon does not exist. So it is very, very important that we observe our oceans and then we understand what's going on in our oceans, as the oceans covers almost 71% of the Earth's surface. So it's very important that we know what goes on in our ocean. So now, why do we have to measure our ocean? Why do we have to observe our oceans? Why do we need in-situ observation? Number one, case one, it helps us to discover unknown phenomena. So without research, without you being curious about what's going on, ocean variabilities going out there, you are unable to discover unknown phenomena. So in case one, because of subsurface mooring, we were able to uncover the subsurface marine heat waves. And this has been a phenomenon. Marine heat waves is a discrete period of prolonged, anomalously warm water at a particular location, and quantitative definition is based on ocean temperatures exceeding a fixed seasonal varying or cumulative threshold. So what we are trying to say is that marine heat wave, it is prolonged, like abnormal temperatures in deep oceans, okay, at fixed positions that vary from the seasonal temperatures we observe. So we were able to, with this, this paper is publicly available. Hugh and Jan were able to observe strong subsurface marine heat waves in the tropical West Pacific Ocean, and it was published in Environmental Research Letters. So with subsurface moorings and having a long-term time series observation of ocean deep temperature, they were able to identify, they were able to observe marine heat waves in the tropical Western Pacific Ocean. So from this, previously, as I said, as you can look at the data, so this is data derived from the subsurface mooring. And on my right, you could see the places shaded in red are the extreme temperatures. So you can see the observation was done from 1998. From 1998 to 2020. We could see 1996, 98, 1986 to 2020. And these are arrays of moorings, okay, in the North Pacific, in the tropical Western Pacific Ocean. All right. So you could realize that from the last, the third and the last, actually in all four moorings, you could realize that there are some places that have extreme temperatures and they are ticked in red. So these are the importance of subsurface moorings, because you are able to get a long-term time series observation of the ocean. You are able to identify, so this is from the surface of the ocean to about 500 meters below the surface of the ocean. And so we could see the places in red where they observed marine heat waves. And so it is very important to understand and how it affects ocean surface and weather in general. Okay, to discover unknown phenomena, case two, there was a discovery of a New Guinea coastal current. That's the NGCC, and a New Guinea coastal undercurrent. And it's very important. The JAMSTEC, Japan Agency of Marine Earth Science and Technology, some in 2003, they were able to observe this current. And this current is subsurface. As we mentioned, it is not surface current. This is subsurface. This is many meters down, below the surface of the ocean. So because this is surface, they used ADCPs, acoustic Doppler current profilers, and they were able to access the long-term time series observation of ocean currents. So from the data on our right, you could see from the surface of the ocean to about 300 meters below the surface of the ocean. And this is very important. So they were able to identify places of high current velocities in the New Guinea. So these currents were named New Guinea coastal currents, and the New Guinea coastal current flows northwest or southeastward during the boreal summer or winter. This seasonality is consistent with a long wind affected by monsoon, and then New Guinea coastal underwater current flows northwestward through the entire period and intensify during summer. For annual interannual time scales, disappearance of New Guinea coastal current and predominance of New Guinea coastal underwater current during 1997, 1998 El Nino. So it's very important. This helps us get a general overview of ocean circulation in general, global ocean circulation. And it's very important that ocean current velocities, underwater ocean current velocities are assessed and discovered. So this is from this, so what was required? They needed an ADCP at a depth of 300 meters and measure ocean current variations in upper 250 meters. So you could see from 0 is the surface of the sea and 300 is the ocean floor. And this was measured so that you can see the places in red, because the subsurface mooring gives you a long-term time series from 1995 to 2000. You could see the places in red where they discovered high anomalous ocean current velocities. So yes, that's very important. So that goes to Jamstech, great research right there. So the case three, actually, there was a discovery of the Mindano undercurrent by Northern Western Pacific Ocean Circulation and Climate Experiment. Actually, this institute actually hosted us. This was an institute that hosted us for the training, and it's called the MPOS in China, the Northwestern Pacific Ocean Circulation and Climate Experiment. As researchers in the Western Pacific, Northwestern Pacific coming together to try and understand what goes on in the Northwestern Pacific Ocean circulation. So they also this Mindano place, actually some buoys were deployed, you know, as we can see in the picture. It's like it's very deep. Sorry, about 8,000 to 10,000 meters below sea surface. So they deployed some subsurface moorings, as you can see, and then they were able to measure with ADCPs to measure underwater currents what goes on in the Mindano. So they were able to have this discovery. So in situ observations help us uncover or discover unknown phenomena in our oceans. Okay, so this is a case theory of the Mindano currents. As you can see, the mooring data right here. Once they were able from 0 to 12,000 meters below sea. Okay, this is the pressure, and so you could see where they are red. You could see high underwater currents, which are very important. So the case 4 is that subsurface moorings help us to identify subsurface mesoscale eddies. So IOCAS and MS-IUP joint crews in 2017 to January 2017, they deployed 30 moorings. They deployed 30 moorings, 30 moorings in the ocean, actually. So what happened was that they were able to discover energetic mesoscale activities in this current. So in this current, they noticed mesoscale eddies activities in the Pacific. So you could realize here on our right, you could see what's going on with the eddies, and then this is cold. Okay, so yes, so we could see what's happening with the currents right here, with the mesoscale eddies right here, and in the picture showed on our right. So these subsurface moorings helped them to be able to uncover these mesoscale activities in this current. And mesoscale eddies activities, they are trapped water, okay, currents trapped together and moving in circular motion. So it's very important. It has effects. When you're able to research, it has effects on our fisheries, even phytoplanktons. Carbon cycle is very important that we measure what goes on in our deep ocean. So I'm giving you cases upon cases upon cases where subsurface observation have helped us to discover unknown phenomena in our oceans. So role of in situ, it also helps us to test phenomena, hypotheses and theories, and it helps us to validate model simulation and predictions. Okay, so we have general ideas. So for example, you are trying to understand the trend of global mean ocean circulation and warming. So we are trying to identify global climate change, okay, global warming, how is it affecting our oceans? What role are oceans playing in it? What are the parameters? What are the variabilities? What are the conditions? What are the similarities? So ocean circulation plays an important role in the redistribution of heat and water masses. So that's very important. So the trend of global mean ocean circulation, we are able to use these to investigate all that. So these are some papers. Would the ocean circulation be accelerating or slowing down warming climate? So actually, yes, that's that. So that was a paper by Dusen Hu. All right. So observations from ocean currents, they noticed that intensified sea surface winds leads to acceleration of global mean ocean circulation. So this was some of their observations, that as much as sea surface winds are increasing, accelerating, global mean ocean circulation are also increasing. And it also means that global warming is also increasing. So they found a common denominator between these three parameters, which helps us to test hypotheses and theories. So in-situ observations are very important. Now, in conclusion, time series data is very highly valued. Okay, it's very important that you have time series data. All right. So when you have a subsurface mooring that has been deployed, it's very important. It helps get time series data for years. You can have station arrays of mooring buoys for years lined up, and then you are able to identify what goes on over a long period of time for us to have better understanding of our oceans. And there's still no suitable ocean observing technology than moorings for time series. Mooring observations have proved time beyond number that it is very suitable for time series observations. But moorings need huge amounts of money. It needs huge funding. It is very, very expensive. I remember during the training, I asked one of the facilitators that it is very interesting because I look at the Gulf of Guinea and I look at the in-situ observation network that we have, but there are not many moorings that I know that has been deployed in the Atlantic or in the Gulf of Guinea, especially in West Africa thereabouts. Because of course, research institutes have to put in proposals, because if they see a phenomenon they want to investigate, subsurface phenomenon, they have to put in proposals to check what goes on and what they have to investigate and all that. So it needs huge sum of money, but of course, there are some moorings in the Indian Ocean here and there. So it needs funding, it's very important. And to maintain observations, we need mooring engineers. So it depends on the mooring system. We also need people like ECOPS, like us, people to also take up programs and specialties in mooring designs. And we shall continue mooring observation. Yes, it's very important. And then we also have to think about reducing risk of failures. So we have to perform very good numerical analysis of offshore moorings to ensure that they are very reliable. And then exchange of information, including failures and improvements, is very important. That institutes that have deployed buoys should share their information on failures and improvements, so that collaboratively we can put together something. And let me put this together. Let me put this across, that collaborative observation between biological, chemical, physical oceanographers is very important. I think the way forward in oceanography is not only a physical oceanographer going to do physical oceanography. It's about putting together chemical oceanographers, physical oceanographers, and if you are putting together a mooring buoy, you can tailor your instruments to fit what you're trying to research. So, for example, if you are a physical oceanographer and you are investigating subsurface currents or underwater currents or mesoscale eddies, you can work with biogeochemists, or you can work with biological oceanographers, see the impacts on phytoplankton, see the impact, the ecological impacts. You can also measure what goes on right there. Biogeochemists, ocean biogeochemists can also make sure they check their nutrients here and there to see, because assessing these things are very important, because some of these things lead to eutrophications, which also lead to harmful algal blooms. So the way forward is collaborative research. The way forward is different aspects or different disciplines of oceanography to come together and put research together. So yes, this is the last part of the presentation. It was supposed to be on mooring data processing. My colleague was supposed to present on this, but he's offshore, so I'm going to take you through. It is very important, mooring data processing, because after you have retrieved your mooring, retrieved your temperature data, retrieved all your data you need. The goal of the data of the processing is to provide a consistent quality control data set. So it's very important, because the ocean conditions are not predictable. So once you put together your data, you have to check. There could be faults, there could be some problems, your batteries of some equipment could go off. So it is very important to monitor your data. So can we directly use collected data? For example, no, it is not possible to use directly. Let's say you take your temperature data and you say, no, I'm going to do data analysis with my temperature data. It is very, very impossible. So we have to first make sure that we detect and then we fix problems. So here, the factors for data quality, okay, these are one of the factors. The deflection is called knockdown. In the picture below, this is the vertical effect, because you have to understand that in as much as your buoy or your mooring is vertical, okay, the waves can make it get some dislocation in its area. So it's going to get a vertical knockdown. And so that is one of the problems. Vertical knockdowns have to be looked at. And we have the escalation. Escalation could be the horizontal change. So say your mooring buoy was 0 meters, maybe about a global origin. By the time you are done, maybe waves, it might have moved about 2, 3, 4, 5 meters in the vertical direction. So it is very important to make sure you fix these issues. Our time, we don't have enough time, so I'm gonna rush this out. And then data quality. So one of the ways to control data quality is that you understand that your mooring is stacked one after the other, is stacked upon each other, the mooring. So one of the ways is to stack your data upon each other. So if your current profile was on top at 10 meters and your salinity ADCP for current is at 50 meters, let's say your CTD is right here, you stack the data on each other. And as you can see from here, there are places where there were no data. It means that there were some problems, and then it will help you to figure out what went wrong and what did not go well. So data quality, acoustic Doppler current profiler. So these are just the format of the data. If you get the data in the ADCP, the data is always in a binary data, all right? So you have to convert it to a MATLAB file, and then you need to do your analysis with MATLAB. And then the ADCP software package itself helps you to present. It helps to present your work. You get the data, you visualize your work, okay? The software is called Win ADCP. Once you get your data, the software itself helps you to present your work in this manner for you to be able to understand what goes in and time series at what time and what's the difference. So it's very important. They have made it very simple. And we also have the current profiler. Most times it consists of ADQ file, different types of file, all right? You first open the HDR file using Windows Textbook, and then you directly load the file into MATLAB, and that's how you're able to do your data processing. We have the conductivity and depth instruments. Also, always, it gives you the software, 37 microcat. The software gives you a visualization or visualizes what you have observed over time. And then you are able to see the abnormalities, you're able to see the variabilities, you're able to see what could be as a one-time error. Then you are able to work on your data. The temperature logger, the same thing, gives you very good representation. The software gives you very good representation. You convert it to text file, and it's available for MATLAB to use. So basically, that is what we have for data processing. Thank you very much. Thank you for your time, for joining us. Yes, Dr. Anthony, I think.
Thank you very much, Samuel. It was a very enlightening presentation. Can you hear me clearly? Can you hear me? Okay, perfect. So it was a very enlightening presentation, and I can assure you that I've learned a lot. I've learned a lot. I've heard about these instruments from a few physical oceanography courses I took before, and I've never really gone into the depth of the actual deployment and how the equipments work. And this is the kind of it's a kind of lecture you get when you probably go for master's or master's course in physical oceanography. And for those of us who are aspiring marine engineers, I think you will not find anything strange anymore once this gets presented to you. So thank you very much for taking this time to do this. Yeah, I have a few questions, but before I do, I'd like to open the floor and see if others have questions as well. So if anyone has a question to ask, including those in the panel, our friends from Indonesia, please just open your mic and they ask, or you contribute directly, either comment or question. So I'll give a few seconds for questions to start rolling in for Samuel. Currently, I do not see questions in the chat.
Okay.
And but I don't know if Natalie is still around. Natalie? Yeah, I think Natalie must have left.
Yes.
But yeah, oh yeah, Natalie's here. All right. Natalie, would it be possible for participants to open their mic to unmute, or we have to unmute them, or you have to unmute them if they want to intervene directly?
Yeah, we can do it. Anyone who is a host, yeah, I can do it. So if someone has their hand up to talk, then I can just let the microphone be engaged. Yeah.
Okay. Please, so if you have a question to ask, just raise your hand and you'll be permitted to ask your question. So yeah, and also comment, not only a question. Let me see something in the chat. Let me see what it is. Okay, someone says very informative, educative, and electrifying presentation. Yes, I agree. It was. Well done, Samuel. So, so let me start by asking, because I have quite a few questions here, and we do not have much time left, so we just have to go quick. Right. So, what does it take for us to have this kind of training in Africa? What would it take? Because you guys have to go to China to have this training. So if we want to have this in Africa to ensure that we have a maximum participation, what would it take?
Right. So per my understanding, first of all, you need an institute that is capable and has the technical know-how, because you need institutions in Africa. For example, in Ghana, there has to be research institutions that have, because first of all, you need vessels, which I believe that it is easy to get vessels in Ghana, but mooring equipments are extremely expensive. So if institutions in Ghana are not already performing subsurface observations or performing subsurface oceanography, and they don't have what it takes, they don't have the equipment, then it becomes very difficult. This comes to my question I asked at the program. I asked him, how much will it take? What will it take for us? I asked the same question. So what will it take for us to be able to have some observations in our waters? And he says, it's huge money to be able to deploy one bull. And Tego is here. All Ayuka's moorings that were deployed in Indonesia, he's like the guy. He was with them. He deployed almost most of them. He was telling me it is very expensive to be able to put together some of these. So researchers in Africa have to be able to find a phenomenon, have to be able to prepare a proposal, to be able to get some funding, to be able to, because I believe that we have the technical know-how. Dr. Bill, I don't know if I got the name right. He was a professor in Cote d'Ivoire. He also came for the training, and he's also a physical oceanographer. So if resource people, if researchers come together and put together a proposal, and it's worth it, because he told me, I said, what if we ask for partnership where we could also deploy some moorings and have some observations? He says, yes, it is very important. We could do that. But then there must be a phenomenon we want to look into. That must be of interest to both of us. So it always starts with as ECOPS, we are now coming up, taking advantage of development programs. So yes, let's pursue PhDs, let's pursue research programs. Let's take up research that can help us come together as ECOPS or come together with international organizations, put together some proposals, and be able to come up with some observation programs. So it is possible, but first we need research institutes that are already, it's either they are already performing such, which, for example, in Ghana, which I doubt, I doubt, but yes, it is possible. If let's say, it doesn't have to be physical oceanographers only, it could be biological oceanographers, chemical oceanographers, depending on what phenomenon you want to look at, subsurface, deep water. So I'm very happy that we have the deep water, African deep water, so we have to participate. come together with observation programs, and then we can have this.
Okay. Thank you very much, Samuel. Yeah, very good answer. And you mentioned something, you talked about collaboration. And that was also where I was going with my second question. So collaborations don't just make themselves, we have to make them, right? So I can also see that you already invited Tegu to be part of this. If you had not invited him, he would not even have known that this was happening, and that's already very good. But what other kind of networking have you been involved or engaged in? And where do you see, given the fact that you guys are now acquiring all this knowledge and skills, and if we do not up our game in Africa, the thing is you would probably just get stuck out there and you never come back because you won't have work to do in Africa, right?
I'm sorry, is it my internet? Because the connection is getting poor.
I don't know. Can you hear me clearly now? Can you hear me? Natalie, can you hear me?
Yes, I can hear you.
All right,
yes,
perfect.
I can hear you.
All right, perfect. So I was saying that, yeah, what kind of networking and have you been engaged in since that training? And also, considering the fact that if we do not really up our game in Africa, start engaging in real oceanographic research, people like you would just get stuck out there and will never go back to Africa because you will not have a job there. So, so now this is a challenge, both for our institutes in Africa and also for you aspiring marine engineers. If you want to return back home and have a job in your chosen field, you have to bring up the opportunities as well. So are you thinking about this, and what steps are you taking in this regard?
Yes, so networking is key. In every discipline of life, networking is very important. So for me, yes, that is why I always try to take advantage of capacity building programs. So it is very important because sometimes if you sit at the comfort of your home or in your school, you would be unable. I wouldn't meet Tego, who, if I didn't go for this program, and I wouldn't meet some very amazing people. So I think capacity building programs in person, the onlines are becoming too much. In person capacity building programs are very, very, very important. And I know the UN Ocean Decade currently, especially, they are doing a lot for ECOPS. So I hope that I think my network is becoming bad. Please, can you hear me? Hello, can you hear me?
Perfectly.
Hello.
Perfect.
Okay. So I hope that capacity building programs are promoted, especially for African ECOPS, and fundings are made available so we can travel to meet people, because it is when you go out there that you're able to put together some collaborations, or even if you're able to meet. I know ECOP Africa is doing very well. We have a WhatsApp group that is perfect. We are always connecting with each other. That's very great. So capacity building programs are very, very important, and they should be made easily accessible. There should be funding, massive funding for African ECOPS to be able to participate in capacity building programs, so we can network with each other. We can network. That is where you get to see what research your friend is into, or what research someone is into, and how we can come together and collaborate. Because if we don't do that, then we will really be far behind.
Thank you very much, Samuel. Yeah, and that's true, and that's also what ECOP stands for, to build this network of early career professionals in ocean space. And I believe that's also where you met Abiwe, because you probably didn't know him before, and both of you are from Africa. So it's very important, and I believe that's already a network that has been created. And as you both grow in your careers, you probably have to come together at some point and decide to do something. Yeah, so that's already really good. Any other questions? Does anyone have something to say in the panel?
If the co-panelists would want to say something, I think they can together.
And yeah, Tegu.
Yes, I would like to sorry, I would like Tego to give us a little breakdown about cost, because I remember when I asked how practical it is to deploy moorings, he was one of the key persons in the meeting that was able to give like a very extensive detail. So he should tell us what's the cost. You know, I would be happy if he's able to at least give us a general view of what it looks like, because he has deployed a lot of buoys. Actually, he has experience in deploying buoys, so he should tell us more about it.
Okay, thank you, Samuel. Good night, everybody in Indonesia. It's maybe is night, is 11 in the evening. So I will inform you to this time in the webinar is not only me and Priyadi join, the other participant from the subsurface mooring training is have joined too. Adi Slamet Triadi and Luciana, maybe you remember, this is join with us. Now he will support to you because I think about the ocean observation is the interesting, but maybe say you say this is the expensive from the instrument and expensive to the conduct the cruise maybe. The budget for one mooring array is about $300,000, similar with the $300,000, and then we must add for the ship cruise. But like Indonesia is development country. We don't have my own mooring, subsurface mooring, because we collaborate with the other country in the world, like from US, from NOAA, and then from Japanese, from Jamstack, from China is from FIO, from IOCAS. We join together to measure the ocean, because you know, the ocean is connecting the one ocean to the another ocean, I think. So better maybe in next time, if Africa country or Indonesia country can join together, make some research together about ENSO, about maybe monsoon, and then ocean default and another, please welcome. You can visit our website, National Research Innovation Agency. We have many program to invite the researcher come to Indonesia, or to conduct the research by the sharing funding with the Indonesia agency. So I think the instrument is expensive, but the idea is more expensive, I think. This is my suggestion to you. Don't worry if you don't have the instrument, maybe if you have the network, the strong network, you can join propose the proposal to the another country, to the rich country like US and another. You have the interesting area. I want to make some research in the Africa about this one. If your research idea is very interesting, maybe the other country will be agree, and he will funding your project, I think. This is my opinion, Samuel. Thank you.
Thank you so much.
Thank you very much, Tego. That's very important what you just said there. Yeah, it's all about building these partnerships, because otherwise some of us in the global south will not be able to do any research. And the thing is, in Indonesia, you guys are doing it, and you have these collaborations, and these collaborations generally are multilateral, and you have countries coming together to collaborate to carry out this kind of research. So there has to be the political will as well. Am I right?
Yeah, because my country is joined with the regional and multilateral organization.
Yes.
Like you indicate, we have maybe next month we have some meeting in Bali to discuss about SDG. You indicate about the marine ecosystem ocean ocean acidification and another problem in our ocean. And then in Indonesia area, we have the name the OUC Westpac. So this is for the regional. Maybe Indonesia is very active to join with another country, because I think the knowledge, the experience is important for us. We must learn from the other country. So the more expert, so we can teach, and then we will practice in our country like that. Professor, thank you.
Thank you very much, Tegu. That's very important. And you just said something as well that is quite important. The fact that Indonesia is very active. And that's also something we have to learn from. We have to get ourselves really active. And I think we should also get out of this mindset of looking at Africa as a country. Africa is a continent made up of 54 countries. So each country should take upon itself, just like Indonesia, to be really active. You don't really have to have the money, you don't have to have the resources, but if you are active and trying to find answers, all you need to do is write proposals and reach out to others. I think that's the take-home message today, you know. So everything someone has described today and the contribution from Tegu boils down to one thing, that you do not really have to be very rich in order to be successful in your oceanographic observations. So we just need to have the will from our institutes. But if our institutes are not ready to do it, then young researchers like us in ECOP will have to push them. So Samuel, I believe that's where we would probably leave it for today. And Natalie, thank you very much for your help. I didn't even know you could make it till the end. So I'm happy you're here. And Tegu, thank you with all of your team from Indonesia for supporting us. And we would definitely be coming back to you for advice. I know Samuel will definitely stay in touch as well. From your experience and everything, I believe that you could really help us as we'll be going into this direction of improving oceanographic research across Africa. Yeah, and Samuel, I would really like to thank you for this initiative, because it was all of your idea. The fact that you went, attended the training, and you didn't want to keep it to yourself, but you decided to share. Even though we don't have as many as we would have expected, but I believe that the videos are available, the recording will be available for others to watch. And it would also motivate young people to want to really venture into marine engineering and physical oceanography, because some stuff was like quite scary. But I mean, what you've just explained, actually, it's more like artwork. It's very much fun. So thank you very much. And any last words before we close, Natalie?
Just a big thank you to Samuel and to you, and to you, Anthony, as well. Yeah. So thank you.
Thanks, Natalie.
Yeah, the recording will be available very soon. So.
All right, perfect. Okay, thank you very much for everyone, and hope to see you again. And good night in Indonesia.
Thank you.
Good night.
Thank you.
Good night in China.
Thank you.
Bye.
Bye.